If you've ever been part of a big software project, you know that feeling. It's not the coding that gets you. It's that huge high-stakes moment of integration.
Hmm.
The whole team finishes maybe 2 months of work, they bundle it all up, and then everyone just waits.
And that fear is just palpable, isn't it? Did my little change from 6 weeks ago break this entire fragile machine?
Exactly. And when it inevitably fails, you're facing weeks of just digging through this monster code base to find one tiny bug.
Well, that risk, that huge delayed failure point, is precisely what modern software development had to get rid of. It's really what defines the old way.
And that's what we're doing today. We are taking a deep dive into continuous integration, CI, and the automated software pipeline that completely changed how software gets released.
Yeah, turning it from this, massive high-risk event into something that's just routine, a low-risk everyday process.
So our mission for you is to really trace that journey. We're going to get into what continuous integration actually is, how it tackles those huge development pain points.
And crucially, the difference between continuous integration, continuous delivery, and continuous deployment, the whole CI/CD spectrum.
Right. And we'll also look at the tools that make it all happen, from, the old standard Jenkins to more modern stuff like GitHub Actions.
This deep dive is basically your shortcut to understanding how the best companies can roll out new features, not once a quarter, but maybe dozens of times a day.
And maintain quality the whole time.
That's the key, the whole time.
Okay, so let's start there with that legacy approach.
Hmm.
The one built on delayed gratification and just massive risk.
It was a very strict linear path. You had code, then build, then test, then release, and finally operate.
And waterfall, basically. You couldn't see what was at the bottom until you were already over the edge.
And the sources are really clear that the risk just piled up in the handoffs.
Yeah, handoffs, right?
Yeah, we're talking about 3 major handoffs between those stages. And each one was manual, it needed documentation, a huge context shift. It was just an opportunity for friction.
So before CI, developers would code for weeks, maybe months.
And they'd wait until the entire thing was built before they ever saw a single test result.
That's the killer. That delay, it creates that dread you mentioned, that feeling of, man, I hope this works in testing, because if it doesn't.
You're in for a world of pain. And the problem was huge. Because this massive code base was all tested together, if one test failed, finding the cause was like finding a needle in a haystack.
You'd have to check the entire source code history, right?
The entire history since the last good test, which could be months ago. There was just no continuous feedback, no sense of whether your code was good, if the build was failing, nothing.
Okay, so if the problem is that massive delayed integration, CI flips the whole thing on its head. It introduces this circular, fast process.
Exactly. We move from that straight line to a continuous loop. Code is build, dash, just release, just operate, and then right back to code again.
It's the immediate feedback that changes the game.
It's everything. The fundamental shift is that developers commit their changes frequently. Not once a month, but several times a day.
Just small, little batches of code.
Tiny, incremental batches. And here's the magic. Every single one of those commits automatically triggers a build, which gets deployed to a test server and then gets automatically tested.
And that's the revolutionary part for the developer, right?
Yeah.
The part that cuts down the stress. Because if a bug pops up now,
You don't check 3 months of code. You only have to check the very last commit you made, maybe the last few.
wow.
It just simplifies bug fixing dramatically. The right teams get relevant, real-time feedback constantly. And that ability to isolate problems down to these tiny changes, it just completely alters the rhythm of development.
So you find and fix defects while the code is still fresh in your mind.
Precisely. And the result is you can release new software way more often and way more safely.
Okay, so let's really pin down the definition then. If we boil it all down, continuous integration is just a practice of frequently committing changes to a shared repository.
Yes, but with one crucial addition, which is immediately verified.
That verification is key.
It is. The sources say that each integration is verified by an automated build and critically automated tests. This lets teams find problems within minutes of introducing them.
Okay, and the sources mentioned 2 ways of triggering that verification, a pull and a push mechanism. That sounds a bit technical.
It's actually a pretty good way to understand the pacing of it. So think of the pull mechanism as like a scheduled bus.
Okay.
The build runs at a set time, maybe every night or every few hours. It pulls in any changes to see if anything's new. It's consistent, but there's a delay.
And the push mechanism.
That's the instant taxi. The build runs the moment a developer saves their changes.
So as soon as I hit commit,
The build starts. It's way more common now because it gives you the fastest possible feedback. A bug barely has time to exist in the shared code before it's caught.
and when you look at the benefits of this, it's not just about happier developers. This has a huge business impact, right?
Oh, it's profound. First, developer productivity goes way up. They spend less time on these massive multi-day integration fires.
And quality must improve.
Immensely. Automated tests are always running, catching bugs early. The sources say organizations using these pipelines deploy up to 46 times more often.
46 times. That's staggering.
That's the real bottom line. Faster updates, lower costs, and way less risk to your budget and your schedule.
And there's an efficiency gain, too, if a developer breaks the build.
They know right away. They're alerted instantly. And the culture demands they have to fix it before they do anything else.
The quality debt doesn't build up.
Exactly. It's like what the software expert Martin Fowler said. Continuous integration doesn't get rid of bugs, but it does make them dramatically easier to find and remove.
It's about containment.
Perfect word for it. It's all about containment.
But this can't be easy to adopt. It sounds like a huge shift. What are the hurdles that the sources point out?
Well, the tools are pretty good these days, but the biggest challenge isn't technical at all. It's the change in organizational culture. If your team isn't used to giving and getting this kind of constant, sometimes, painful feedback all day long, it can be a really tough transition.
And I imagine just maintaining the system is hard.
That's the other big one. The difficulty to maintain a complex text system and also just dealing with the sheer volume of error messages. You need a good system to sort through all that noise.
Okay, so CI is our foundation. The automated build, test, merge phase that gets our code ready.
Right. And make sure the code is healthy.
But then come the two CDs. Let's start with the first one, continuous delivery.
So continuous delivery is the next logical step after CI. It's about taking that clean, validated code and automatically building, testing, and delivering it to an environment where it's ready to go live.
So the goal is just to make sure new changes can be released quickly.
Exactly. The testing, the creation of the final product, that's all automated. But, and this is the key point, there's a human decision point right before it goes to customers.
So in continuous delivery, the actual deployment to production is a manual step.
Right. The sources call it the just one click of a button release. The process isn't hard anymore. It just needs a person to say, go.
Which is still incredibly powerful. It gives the business the control to release daily, weekly, whatever they need.
It does. It speeds up the customer feedback loop, but it keeps that final safety check in place.
Okay, so that leads us to the final piece of the puzzle, the second CD. Continuous deployment.
The holy grail of pure automation.
If delivery has that manual click, deploying it must get rid of it. But isn't that risky? Aren't you just automating the ability to break production faster?
That is the essential question. And yes, continuous deployment aims to make the time between writing code and having it live in production virtually zero. The whole process is fully automated.
So what are the guardrails?
The guardrails are baked into the CI foundation we just talked about. The automation only moves forward if every single automated test and monitoring check passes with 100% success.
So if one test fails,
the whole thing stops instantly. The deployment is blocked.
So the confidence comes from the rigor of the testing, not from a person reviewing it.
That's it. And what the business gets in return is the fastest possible ROI on new features. They're live and creating value immediately.
And it's less risky because the changes are so small.
Much less risky and much easier to fix. If an issue does get through, you know the cause is in the last few minutes of work. Development never has to stop for a release ever again.
So that's the key contrast. Continuous delivery prepares the code for a manual release. Continuous deployment automatically releases the code if it passes all the checks.
One is ready to ship, waiting for a signature. The other is shipped the instant it passed inspection.
Perfect. Okay, to make this all happen, you need the right tools and the right process. The sources point to 5 pillars for a successful CI/CD pipeline.
Right, these are the guiding principles. You need automation, transparency, speed, resilience, and security.
Automation and speed seem obvious. What about the others?
Transparency means everyone on the team can see the status of the pipeline at any time. Resilience means it can recover from failures gracefully. And security means you're building automated checks like license compliance right into the process itself.
And when you get those 5 pillars right, the benefits just stack up.
Yeah.
We talked about fewer handoffs, meaning less complexity.
Mm-hmm. And the metrics are just profound. You go from one big deployment a month to maybe several deployments in a few hours.
It must also improve how fast you can fix things.
Absolutely. It drastically improves your MTTR, or mean time to resolution, and developers get so much more confident because they know they can fix things in minutes, not weeks.
So let's talk about the tools that orchestrate this. The big one, the classic, is Jenkins.
Jenkins is almost always the first name that comes up. It's an open source automation tool written in Java, built specifically for CI. Its real power is its massive plugin ecosystem.
What do you mean by that? What do the plugins do?
They let it connect to basically everything else in the DevOps world. It integrates with your version control like Git to see when you commit code.
Okay.
Then it connects to build tools like Maven to compile it, sends it off to testing frameworks, and can even handle deployment and connect to monitoring systems like Nagios to watch it once it's live.
So it's a central hub, the conductor of the orchestra.
It really is. It defines the whole workflow as code.
The sources also had a really cool insight into its architecture, because you can't just run everything on one server. What if you need a Windows machine for one test and a Linux machine for another?
Right, that's where the Jenkins distributed architecture comes in. You have a central Jenkins master server that acts as the brain.
Control plane.
Exactly. And that master hands out jobs to multiple Jenkins slaves or agents, and these slaves can be specialized. You can have a Windows slave, a Linux slave, whatever environment you need for a specific job.
And that helps manage spikes in work too, I'd imagine.
For sure, you can spin up more slaves when you need them, and the sources note that because it's cloud native, it's often best to run it on something like Google Cloud or DigitalOcean to get that elasticity.
So Jenkins is the classic standard.
Yeah.
But the game is always changing. We have to talk about newer solutions like GitHub Actions.
Yeah, GitHub Actions is part of this modern trend of building CI/CD right into the code repository itself. It's a full CI/CD platform that automates everything.
And it runs on virtual machines that GitHub provides.
It does. They're called runners. And you can get Linux, Windows, and Mac OS environments right out of the box. It basically removes a huge infrastructure headache for teams.
So it blurs the line between your code and your build system.
Completely. It makes getting started so much faster. You don't need to be a Jenkins architecture expert anymore. It's a huge reason the industry is moving toward these unified, integrated platforms.
And of course, we should mention the other big players the sources name, like BuildBot, Travis CI, Atlassian Bamboo. They all play in this space.
Yep, it's a rich ecosystem.
So when you pull back and look at the big picture, what does this all mean? We've really seen a massive philosophical shift, haven't we?
Oh, absolutely. We've moved away from that painful, months-long waterfall model with its huge, risky releases and delayed feedback.
And moved toward a system that's just a rapid, continuous loop.
A loop of frequent small changes, maximum automation, and constant real-time feedback that validates every single change. This whole continuum, CI, delivery, and deployment, it's not just a set of tools, it's a culture.
A culture where quality and speed are engineered into every commit.
Right, and that transformation from developing over months to deploying constantly, it just radically changes the entire business dynamic. The sources say development doesn't take a year anymore, it's measured in minutes.
So here's something for you to think about as we wrap up. How does this relentless chase for speed and quality, this ability to develop and release in seconds, how does that change the fundamental relationship between a business and its customers?
It's a great question because it transforms the product from, a static thing that gets an update once in a while into a persistent, evolving service that is constantly being refined and improved, all based on perpetual real-time testing and feedback. It's a living thing.